Moving to our last team, COD3INE. So the team members are Chanakya, Nitya, Vikrant and Varsha, and they are going to present their solution ODMAS. So calling Chanakya on stage.
Good afternoon, everyone. This is Chanakya Gacharupu, and I represent Team COD3INE. We are here today to talk about this fundamental gap which is in the digital security background. And we are going to tell you how we came up with a solution which is an AI solution. Going directly into the problem, every time you unlock your mobile phone, you basically open a door. And we all know that checkups are only done in the doorway. But for the section which continues, once you are inside the door, there is a gap. And this is a security gap. So basically what I'm saying is, this is the place where your mobile is most vulnerable because it thinks the person who is using your mobile phone is you. Even though you might have unlocked your mobile phone and pass it on to the next person, right? So things like this. So someone might have used the password. So this is the security gap. And this is the problem statement. There are a few cloud solutions for this who tried to use cloud to solve the solution, and it didn't work out because you have many complications with cloud-based thing. So what they did is they gave the behavior biometrics onto the cloud, and here you have privacy concerns, you have latency issues, and it's not always reliable. That's where our solution comes, which is ODMAS. ODMAS is on-device multi-agent security system. It's not just any application on your mobile phone, but here, this is on-device intelligent system which continuously monitors what you're doing and gives you a living behavior biometric, a fingerprint basically. So here we use multiple agents like So here we use multiple agents, which I'll be saying you soon, and there is a unique value proposition. So you might ask, what is very unique here? Starting, we created ODMAS using 3 pillars as base. 1, the privacy. 2, user experiences. 3, the multi-intelligent agents. Starting with the privacy, you can call our ODMAS a privacy fortress because number 1, it's completely on device. Number 2, there is no data exhaustion. Number 3, all analysis is being done on device, and even small storages, like for example, you see there's something called baseline. So even a small storage which is supposed to be stored uses high-level encryption methods like AES, DCM, and so on. And next, going into the multi-agent intelligence, ODMAS is a symphony which has many specific multi-agents. So here we have agents which work on statistical extraction, which is a deep learning model, and which is also a kind of machine learning which always have a real-time learning. So all these agents work under a hood, and in this way, this gives you better results, accuracy, and faster response time when compared to any other individual model out there. And going to user experience, though this is a security application, we don't want to go down on the user experience. Because one of the biggest challenges we face is false positives. Imagine you're using a mobile phone and you get a false negative, and that's not you. So that basically says your application is not good, right? So we introduced something called trust credits, where you'll be given 3 to 5 trust credits, and if the mobile phone thinks you might be, not you are, you might be an anomaly or a bot, it gives you 3 chances in the 3 specific windows. If it's not done on time, then it will get back to giving you a password. It will ask for the password, and in our case, password is fingerprint. Okay, so on a bird's eye view, there are 5 agents. 1, Tier 0, Tier 1, Python, Jacobi Python ML, the Fusion agent, and the policy agent. Tier 0 and Tier 1 are the primary baselines here. Tier 0 being, this works completely on Mahalanobis and chi-square. So this takes 10 up to 10 dimensions of touch patterns and typing parameters, like your dwell time, your flight velocity, your pressure, the number of pixels being touched for each and every touch, so on. And then the Tier 1 agents. This acts like a confidence booster for Tier 0 agent, while this is working on Z-scores and moving averages. We also have one more agent in the last, which is called optional Tier 1. So this is basically an add-on gated agent for the Tier 1, because here, rather than using statistical behavior models, we are actually using a deep learning model in this. But we all know you can't implement a deep learning model completely in it and and see for the best performances, right? So that's where we use this way that if in case your baseline, your calibrated baseline is in a good quality, that is only when this new, the last agent gets on. And if in case it's bad, it goes back. This is basically to reduce the flicker and shuttering of the application. Okay, now let me give you a brief of each and every tier. So starting with tier 1, it's a statistical agent. As I told you, it's going to take your touch parameters, the typing parameters. It takes the windowed features parameters, and within 10 milliseconds, it converts it into the Malabarist distance and also Malabarist distance into the square root of pie chart, which gives you the final risk number. And then the tier 1 agent. And then the tier 1 agent. Here in the tier 1 agent, we are using Z-score, moving averages, and so on. And this will be only working if you have a proper parameters. So we are not taking an option where we don't have enough parameters. So once you have enough parameters, this T1 will be working as a behavioral agent. This uses Z-square and moving averages as the method. Next, this is the autoencoder which I talked previously, the last agent. This agent hops on to this T1 agent when you're having a very good baseline. And if you have a good baseline, this is the deep learning expert. So it actually learns your app interface behavior, the way you're using your apps. Even let's say you open WhatsApp and then you go to Facebook. So it also learns which app is being used when, so that it creates a baseline, a proper authentic baseline. And next, we have this Jacobi ML agent. This Jacobi ML agent is basically you can call this as a coordinator. What this basically does is this works on those agents. See, you might have already noticed that we have multiple agents, and not all agents at all times are doing their best. So sometimes maybe with the memory overflow or context overflow, they might be having a bad output. That is when this Jacobi ML hops in. So if an agent is continuously giving some tired outcomes, then this hops in to give you like a second opinion. So no matter some random user hops on to do the same actions as I do, then this Jacobi ML will hop on so that this system is foolproof. Going next, we have this fusion agent. So basically with all the other agents, every agent is using their separate methods to give you a risk value. And you can't use multiple risk values to give you one output, right? So this is where the fusion model works. It uses combined agent risk with confidence adaptive weights. We have given different weighting for each and every agent, so it uses those weights and gives you a final output. Here, it combines all the risk analysis from each and every agent to give you one final answer. Going forward, this is the final one, which is the policy agent. Now, all the agents worked. Everything gave its answer, and you have one final answer, which is the risk value. Now this policy agent is going to take care if I'm supposed to say it's an anomaly or it's not an anomaly. And this policy agent has something called sticky escalation until biometric success, which means, let's say you open a biometric and I swiped it back, it will still ask for a biometric. And also the credit system which I talked about, that credit system is also part of this, so that if in case you are not having a critical state, only a bot can do a superhuman behavior. Not almost every other human, it's more or less similar to each and every person. So this is where this uses this credit system, waits for a specific window, maybe 30 seconds, 5 seconds, and if it continues, then it's going to flag it as an anomaly. So I'll tell you how this is working in a live demonstration. See the working of the application.
Opening it, the first time you open it, you're supposed to give it a few permissions so that the app is going to work the way it's supposed to.
I gave the permissions.
And once that's done, let us calibrate it for the first time. You're supposed to do minimal activities like swiping, scrolling, and just normally using your.
This is the calibration part.
So that your phone.
I'm doing touch calibration.
How are you using it?
By doing normal swiping, touches like I generally would. So now the application is learning the way I touch and swipe this.
Now it's asking me for a calibration to type in.
Now this is the typing calibration. So it will give you a paragraph over there. You're supposed to redo this, so it will learn the way you type. And these are the stats. Okay, so that's a very big video, and that's been done. So previously, those are the stats. You might question how did we create a stat there. So every time it asks for an anomaly, you can either say if it is yes, it is an anomaly. No, it is not an anomaly. If it is an anomaly, then it's going to block the application on the mobile phone. If it's not an anomaly, it's going to learn the previously used stats. And ethical and scalability. Now we all know creating a powerful AI agent is not sufficient for something, for an application which is going to be used by millions of users tomorrow. So we used privacy and ethical concerns not just as features but as core principles for our application. So with our progressive modern interactions and our adaptive learning, this could be integrated in all the edge devices like web devices, wearables, and even on the laptops. So that is COD3INE, and this is ODMAS for you. Thank you so much. We want everyone in this world to use our application so that they are very secure from third-party anomalies. And you can try this APK on odmas.gajrapo.com. You can download the APK and try for yourself. Thank you so much.
Hello. So agents don't need to be explicitly programmed as far as the planning is concerned. But it seems we have done the planning also programmed, not only the. So it is not actually a multi-agent solution. It can be probably called as agent of agents or agent of modules, kind of. It's probably not multi-agent solution.
Okay. We are calling this multi-agent system because in the tier 1 agent, there is touch detection, typing pattern agent, and motion detection agent. So each one focuses on different kind of recognizing user patterns. So when it comes to typing patterns, this conventional neural network will just focus on fewer parameters and fewer patterns of the user. When it comes to motion, it tries to capture certain personal signature of the user. So because an agent is something that does autonomous work and interacts with different tools. So here they're interacting with different tools, and because
Correct. My only point is every accelerator is not autonomous. They are not doing the planning by itself. You have an umbrella agent who finally does the coordination, right? So better to call it as agent of modules or agent of agents, not multi-agent. Multi-agent means there are multiple agents. They all are doing their planning.
yes, pattern agent doesn't coordinate with the typing pattern and the touch and the motion. They act in separate, but their outputs will be given to the fusion agent to coordinate the result.
Yeah, then you cannot call it as multi-agent. That's what my purpose.
That is partially true, but also this fusion agent and other agents which are working on the first agent, though they are using the parameters of the other agents, this first few agents are being worked on their own. And in a very classical example, they might not be completely called as an agent, but in the modern terms, this is one of those.
So for the weight distribution part, how you are defining the weight for the optimal output in the fusion?
Sir, it depends on. First, it depends on if the window is very small. Just user comes and goes away. If it is less than 10 milliseconds, then we go with only statistical agent. When it comes to the fusion model, it uses 10% of statistical agent, that is T0, and it comes when there are our three different agents like motion and typing pattern and touch. It carries 60%, and then finally the Chekopi ML analysis carries the rest 30%. This way it showed us a better result as compared to different weight formats.
Thanks for the presentation. So what kind of data do you have? Like, as time progresses, I presume your accuracy or your strength of your security improves. So what is the trajectory that we are seeing with this?
Yeah, so basically the first time you use the application, you're supposed to give it a normal calibration baseline. This is the only data which is as in the very first experience. But there is something, we also use adaptive learning. So the risk dial, you could have seen that if in case you saw the whole video, there's a risk dial in this. So from 0 to 40, we are calling it low. From 40 to one part, it's medium, then high, and then critical. Until and unless your risk dial is in the normal, low, 0 to 40 range, whatever you do, like touching, swiping, typing, all this will still be used as a parameters. So the more you use the application. We saw changes in 1 hour of usage also, but for 1 day, for 1 week, you can see more accuracy in anomaly detection. So with our changes from the past 10 days, we use a mobile case for the past 10 days, and then we saw an upward increase up to 95% anomaly detection. It is only recognizing it as an anomaly if and only if the original user is not using it. So it has real-time learning, which is adaptive, and it only works when the risk dial is in the low percentage. And if in case, let's just say it gave you a false negative, and it unfortunately told that you are a bot or something. In this case, this sometimes happens because it's a part of the learning curve. So you give it your fingerprint, say that I'm the real user, and simply say that verify, this is me. then it will have a 8 seconds of grace period. This is where here further next 8 seconds will also be taken into consideration because it is not in the 40% range, but still will be taken into consideration. This basically works when you're using 2 fingers, 1 finger. So it says you're an anomaly. Again, you say I'm not an anomaly, then it relearns it.
Thank you, Team Cody. Now I would like to invite all the teams to the stage and our grand jury members. And Mohan, please come on stage.
What is the real thing inside? Inside fitting it. Yeah, everything is fitting.
సార్ ఎఫర్ట్స్ ఇద్దరు వాళ్ళు పే చేశారు.
A huge congratulations to both the runner-up teams. And now it's time for the big one. The winner of the AI challenge is Team Cody.